I'm gonna start recording. Okay, so what I've posted on Moodle for everybody is sort of the first week. That's about as far as I could look. And the first 2 days of that, of course, were just like review and whatever. I now have a subscription to Zoom. They are not going to cut me off after 40 minutes, which for you guys, class is only 50 minutes. And when somebody cuts me off at 40 minutes, I just want to say, forget it. But for the nice price of $15 per month, they said they'd give me unlimited time. And I'm like, thank you very much. I thought they were going to do for academics. I thought they were going to, for people that were teaching, I thought they were going to give us free time, but I didn't have time to wait around to find out. So anyway, we're good. We're not going to get cut off. That's a good thing. On Moodle, starting today, there are problems to do. And that'll be the homework for tonight. It's what I talk about today. I have tried to hit the highlights in homework instead of swamping you with homework, but you need to be careful about doing it because each one of these next lectures really depends on the one before it. And we're building a system for how to use derivatives in more ways than we learned in the previous half a semester. So there's a few terms and so forth to learn here, but they're not that hard. So what I'm going to do is go ahead and share my screen with you and start talking to you about what we're going to do. Oh, I don't want to register for Q&A. Leave me alone. No. Get this out of the way. Uh-oh. Now I've lost you. Can y'all see me?
Yeah.
Okay, let me just do this again. All right, I trust the computer. All right. Okay. Whew, that made me nervous there for a minute. Okay. Okay, so guys, what we're doing right now is starting chapter 3. And it's another way of using derivatives, some of which we've kind of already learned. I tried to like say certain things during the last half of the semester where where I was hinting to you about what I was going to do in the future. And one of those things is talking about where functions are increasing or decreasing, okay? And there's a way to use the derivative to find out whether they're increasing and decreasing. But first of all, let's talk about what increasing and decreasing means. Basically, if you look at this picture right here and you go from left to right, if your hand goes up when you're drawing this thing, that function is increasing. Think about it as a profit curve or something. As you produce things, the profits are going up when it goes this way. The fancy math definition for doing that is saying if x2 is bigger than x1, then f of x2 up here that's the y value, f of x2 is bigger than f of x1. Okay, that doesn't look very good. Let me get that out of there. Okay, f of x2 is bigger than x1. But just from a visual point of view, guys, if you're going from left to right and you're going up, your y values are going up, that's what you're looking at. You're looking at increasing, okay? So next, if you look at something that looks like this, what you're looking at is going from left to right. And if you trace down here, you'll see that it is decreasing. Think about it as decreasing profits or decreasing temperatures, and this might be time or something like that. But it says if this is bigger than that, if this is bigger than that, this is bigger than that, then when I look at the y values, say f of x2 and f of x1, now remember those are y values. When I look at those y values, f of x2 got less than f of x1 because I'm going from left to right here. And again, if you trace it and your hand's going down while you're doing that, it's decreasing, okay? So that's what increasing and decreasing mean. Anybody question on that? I got some examples, so we'll look at what the examples do. So there's one other thing that can happen, and that's that the function can be constant, In other words, if we're going right along this plateau right here, things are staying constant. They're neither increasing nor decreasing. So for x1 and x2, the values of your function f of x1 and f of x2 are the same. They don't increase or decrease, they just stay the same. That would happen on a horizontal piece of a line there, guys. Just a horizontal piece of a line. Okay. Now, so that's three things that can happen: increasing, decreasing, and constant. Now, let's put a whole graph together here. And I want to talk to you about how we state where something's increasing or decreasing. There's this picture. It's got a lot of ups and downs and plateau and then down again and so forth and so on. When you talk about where something's increasing or decreasing, you do it along the x-axis. So for example, if I said, let's look from 2 to 4, it's pretty clear here that the function is doing what. Now, you guys got to talk to me, okay? So what's going on from here to here in between 2 and 4?
It's increasing.
It's increasing. I mean, I'm going up. I'm going up, right? It's increasing. If I look right here, and actually, I got a problem with that point right there. That point should be like, instead of, it should be like 10, 7. Okay.
Quick question: are you gonna put these notes on Moodle?
Yes, I put those other things on Moodle. Did anybody check the Moodle site for the review notes? I put them up there, so the link should be on there, and I will do that with this too. It'll take me till maybe, I've got classes all the way till about 3 o'clock, so I'll try to do all that this afternoon. But I'm recording it, and I'm putting it up as a post on Moodle. I mean, and it's on Moodle as a YouTube video, guys, so you just click on it, it sends you to the YouTube video, and you see it, okay? So that's a good point. That's a good point to start with and remind ourselves of. Ask me questions. You'll hear me answer them. You need to hear me answer them again. And then just go on that, go on that YouTube video, go on Moodle, bring it up, and you can see it again, okay? That has an advantage over, I can't think of many advantages of this over other things, but that's an advantage, okay? So if I say right here, it's pretty clear that if that's 10 right there, there's an error in my notes, that starting at 10, it's doing what? What's it doing right here?
Decreasing.
Is that increasing?
Decreasing.
Decreasing, yeah, that's decreasing, okay? So here's the way we talk about it. Think about this, and this is sort of doesn't play into this picture very well. But if you want to know where something's increasing or decreasing, you label it down here. So for example, if these were times and these were temperatures, and I would say, where's the temperature increasing? You would give me a time. You would not give me the temperature, you would give me the time. So here's how I'm gonna do that. I'm gonna look from left to right on this thing and see what it's doing all the way along. Now, let me indicate to you that right here, that's just indefinitely going down, but you're reading from left to right. So as I come from left to right, and that's out here is minus infinity, and here out here is infinity, you just told me that this thing was increasing here. Now, here's the way I write it. I don't write the points. I do this. I look on the x-axis and I say, well, the y values are increasing from minus infinity up to minus 1. So the first thing I'm going to write is minus infinity to minus 1. Now, that's increasing. That tells me the y values are increasing there. I don't put the point there. I just put the interval. And the interval is from here to here, and that's where we get this increasing situation here. So minus infinity to minus 1. So let's finish it and make sure you understand it. I'm sort of got not much room there. What's it doing next, guys? And I'm looking at, I've gotten to this point right here on the x-axis. What's it doing next?
Decreasing.
It looks like it's decreasing, doesn't it? If I trace down there, it's decreasing. And it's decreasing all the way from minus 1 up to 2. Okay? So if I said, let's see, let me use some of my fancy capability here. If I looked at that, so it's decreasing in between here, all right? So this is coming down, all right? We write actually from minus 1 to 2. Guys, and that is not a point, guys. That is an interval. That's an interval. We do not deal with points. We just deal with x values here. Okay. All right. What's it doing next?
Increasing.
All right. It looks like I lost my. Let me change my color here. All right. Right here, starting at 2, it's going up. So where is it increasing? How would I write that as where it's increasing?
From 2 to 4.
From 2 to 4. All right. So right there is where it's increasing. So it's increasing here. That's from 2 to 4. The way I'll indicate that, guys, is put a union symbol because it gets linked onto the other piece. It's increasing from 2 to 4. So that's what I look at there. All right, I'm going back to my red marker here. I can see it better. Okay. All right, let's look next. What's the next thing it's doing, guys? Okay, we got up to 4. What's it doing next?
Decreasing.
It's decreasing until we get to what x value?
5.
Until we get to 5. So I'm going to go down here. I'm going to put union 4 to 5 is the next place it's decreasing. Okay, I made this a long example. We'll have it by the time I finish it. What's it doing next? Once it gets to 5, it turns around and then starts doing what?
Increasing.
Increasing again. So I write that as 5 to 7. So I link it on here, 5 to 7. So I made it up to 7. What happens next? What appears to happen next?
It's constant.
Constant, and you can sort of see that because it started. Gosh, I made a. Let me fix something here. I don't know what I was thinking about here, but it wasn't the right thing. This is it was at a height of 5, and it ends at a height of 5. Sorry, don't do that. This is a benefit of, again, me being able to correct, and I can put it on the video. So it's constant. So I need another thing here. I'll just write it right here. That's the only place it appears to be constant. And so I write from 7 to 10. Okay, all right, from 7 to 10. Only one more thing to look at. And what's the next thing it's doing after I get to that point? Once I get to 10, what's it doing?
Decreasing.
It's decreasing. What do you write there, guys? It's decreasing. It goes down in this spot right here, but what do I write?
From 10 to infinity.
It looks like to me I've indicated that it's going to keep on going down. So I write 10 to infinity. Now, a comment about my notation. These are intervals. We're used to asking ourselves questions about, well, do we put a parenthesis to include the point or a bracket to not include it? It's the way I do it is I just always use parentheses here because really when you talk about what's happening at 5, interestingly enough, we'll talk about this later, it stops decreasing and starts increasing. So it's neither increasing nor decreasing there. So that's why I put open symbols, parentheses on there instead of brackets. Okay, that's important. Anybody got a question on that? You might see the first part of your homework. You might see some things that say indicate the intervals where this is increasing or decreasing. That's what they're asking you to do there. And yeah. So look at that and make sure you're getting what they get in the back of the book. And if they use brackets in the back of the book, ignore it, okay? I don't remember what they use in this book or that book. Okay. So let's keep looking here. Oops, I already had constant down there. I forgot. Okay, there it is. Constant was 7 to 10. 7 to 10. Okay. All right, now let's look at the next slide or next thing. All right. So my next question is, what if I gave the function without the graph? How could I tell from the function that was increasing or decreasing? In other words, I don't have a picture to go by. So what's nice about this is if you look at this thing right here, this is increasing. This is increasing. You can clearly see it's going up there on that interval. Now, the other thing that's interesting in the connection we're going to make is that if you were to draw a tangent line to the curve there, remember what the tangent line to the curve was? It means that's the derivative. The slope of that is the derivative. What kind of slopes are these where you got increasing? Look at all those lines I'm drawing. What kind of slopes are those, guys? Positive or negative?
Positive.
Positive. So increasing indicates positive slopes. Or if you have positive slopes, that means your function is going to be increasing. And what are slopes of tangent lines? They're just derivatives. So the conclusion from that is if I have positive derivatives, I have increasing. Okay? So I write like a 5-year-old with this stupid pen, but whatever. If you can't read it, let me know. So big thing there. Increasing means positive slopes of tangent lines, and that means positive derivatives. All right, let's keep looking. If you look at this next one, it says, actually that's the first thing. The conclusion in math speak is if f is differentiable on AB and f prime of x is greater than 0. Now that means greater than 0 would mean positive. So if you have positive derivatives, then f is increasing on AB. Okay. Now let's look at the next. Let's look at the next thing. If you look at this one right here, it's pretty clear that that function is decreasing there. Okay, and by the same logic I used a minute ago, if you draw these tangent lines, those tangent lines to curves have negative slopes. Those tangent lines have negative slopes. Right? Now, negative slopes, because the tangent lines to the curve is the derivative at that point, that means negative derivatives at those points. Now we'll have a process for telling whether the derivatives are negatives or positive in a minute, but the idea is the function is going to be decreasing if these two things, if this thing happens, if the derivative, okay, if the derivative is negative, we're going to have a decreasing. So if you look at what I wrote here, it says if f is differentiable, then f prime of x is less than 0. Less than 0 means negative. Okay, on AB, then f is decreasing. There's only one more situation here, guys, and that is if it's constant. So for example, if I had a function that leveled out like that, let's say, what would the derivative be right in there? What would the slope of the tangent line to the curve there? If I drew a tangent line, it's the same line. What kind of line did I just draw? Horizontal or vertical?
Horizontal.
Horizontal. And what's the slope of a horizontal line?
0.
0. So anywhere you've got a derivative of 0, then the function is constant. Now, that's over a period of time. It's over some interval there. We've talked about derivatives of 0 being at these these horizontal tangent lines, but that derivative stays 0 just for an instant. If you're talking about an interval, what happens is you will have this horizontal piece, this plateau, basically. Okay, so problems, anybody with that? We're going to talk a lot about how to use this. But going up, increasing positive derivatives, going down, decreasing negative derivatives, staying steady, derivative would be 0. If I move on too fast with the pages, guys, please let me know. You're going to be able to watch this again, so it may be a second learning experience to look at it and take notes where you can stop me. Okay, so let's look at an example. Here's the way I'm going to analyze this. I'm going to take a function, and we all know what that one looks like. We've used it a million times just because it's a really good example. And I'm going to take the derivative of that, and the derivative of that thing is 2x. Easy power rule. Now, the question is, where do things go from being positive to negative? Well, on either side of something that's 0. On either side of something that's 0, to the right of 0 would be positive, to the left of 0 would be negative. So what I do here is I find out where this is 0. Okay, well, where is 2x equal to 0? That's an easy one. Where's 2x equal to 0? Just at 0, right? If I set that equal to 0, x would be 0. So I'm going to put this function, this derivative, let me do with it. Hang on a second. So what I would say is that f prime of x equals 0 at x equals 0. At x equal 0. Okay. So what I'm going to do with that spot where it's equal to 0 is put it on a number line. And then I'm going to test the derivative, because that's what I'm interested in, knowing whether it's positive or negative. I'm going to pick a point over here to the right of 0. Pick a number. I don't care what it is. If I pick 5, and I plug 5 into the derivative, twice 5 will be 10. Is that a positive number or a negative number? Well, clearly positive. I don't care that it's 10, I just care that it's positive. If somebody else had picked 3, 2 times 3 would be 6. That's positive, so I put positives over there. And you only have to pick one test point. Be careful with it though. If you pick 15, twice 15, still positive. To the left of 0, I don't know, suppose I pick -2. If I go up to the derivative and plug in -2, 2 times -2 would be -4. That means the derivatives over here are going to be negative. So we've got negative. This is indicating the signs of the first derivative, guys. It's indicating what the first derivative is. To the right of 0, and you always test it in the derivative. Don't go back and test it in the function. You're finding out whether the derivative is positive or negative. Positive means increasing, and negative means decreasing. So look at when I've got this chart, I can say, oh, let me see what happens here. Since it's positive derivatives here, I'll draw a little arrow and say that means increasing. It's going up. I can write increasing on it if I want to as well. Maybe I can write increasing on it, but okay. Increasing, put the little arrow up to remind you of that. On the left-hand side, the derivatives are negative. Well, if derivatives are negative, we said this thing was decreasing. So I'll go over there and say, okay, well, that means over there, I'm going down. That means I'm decreasing. So how does that play into what the graph looks like? Well, one thing that's nice is that I know where this graph's increasing or decreasing. This is a really obvious one, but look at how it works out. If I take the point where it breaks there, where sort of things might change, and I put it into the original function, I'll get a point on the graph. So I know that that's a point on the graph right there, guys. That's a point on the graph. I also know that it's increasing from 0, over here from 0 to infinity. So if I started to draw this thing without knowing what it looked like, I would say, okay, well, it's got to be going up there because it says it's increasing from 0 to infinity. On the other side, that's where it's increasing right there. We said it was decreasing to the left of 0, all right, to the left of 0. So I would have said, okay, there's 0, to the left of 0, it decreases. Now, this might be important later. Well, it's important right now. The derivative is 0 at 0. Notice there is a horizontal tangent line, okay? As far as increasing, so at 0, there's a horizontal tangent line. But to the right of 0, function's going up. Left of 0, function's coming down. Then you can plot some points on it. I mean, if you really want to nail down the graph in terms of just what some points on it, just pick a couple of points. I mean, I know that 1, 1's right there. I know that 2, 4 is up here somewhere, and so on. But in general, it's got to look like that. It's got to look like that. Okay. Big idea for what we're getting ready to do for the next couple of weeks. Okay. Increasing derivative is positive, decreasing it's negative. Anybody have any questions? Okay. All right, let's keep going here. So clearly that point where the derivative equals 0 is important. And for that reason, it's called a critical number. So it says if f is defined at c, in other words, the function exists there, we don't have a discontinuity, but if it's defined at c, then c is called a critical number. In other words, when f prime of c equals 0, or f prime of c is undefined. Now, we'll talk more about that later. The function has to be defined there. But any place where the function is 0 or the derivative is undefined, assuming the function is defined there, you're going to have what's called a critical number. So let's do the critical numbers for this function right here. The first thing I have to do is take the derivative. Now, guys, the importance of derivatives here and doing them properly is you take the wrong derivative, this whole process, which is going to be fairly long, just goes to pot, okay? So you got to be careful with your derivatives. So what's the derivative of 2x cubed? Let's look at that first thing. What's the derivative of 2x cubed there?
6x squared.
All right, 6x squared, that's good. What's the derivative of 9x squared?
18x.
18x. Okay, now here's where the rubber hits the road on being able to factor. You got to factor this thing, okay, to find out where the zeros are. So I'm going to factor it in order to find the critical numbers. What will factor out of that, guys? Tell me what you can pull out of that thing. Remember, the first law of factoring is pull out what you can from everything. It's not a trinomial, so I'm not going to do that.
6x.
I can pull the 6 out of both the 6 and the 18, and I can pull an x out of both here. So I'm going to pull out 6x. What's left? What's left?
X
X minus 3?
Mm-hmm.
Perfect. Okay, x minus 3. Okay. Now, so when I get that, I can find the critical numbers by finding where this is 0. So tell me where each one of these factors would be 0 here. Where are those 0?
At 0 and 3.
At 0 and 3. You just take each one of these and set it equal 0. So x equals 0 and x equals 3 are what we call these critical numbers. Okay. So what am I going to do with them? I'm going to put them on the number line, just like the last one, except the last one wasn't quite this complicated. So I'm going to put a 0 on the number line and a 3 on the number line. And I'm going to be careful to put them in the right order, okay? The smaller ones go before the larger ones. You mix them up order-wise, nothing makes sense, okay? So 0 here and 3 here. Now notice that by putting the critical numbers on there, it split the line up into 3 spots. I've got to put a test point in each, I've got to find a test point in each one of those spots. So let's try a test point. Give me something bigger than 3, and I don't care what it is. First person in. What's bigger than 3?
12.
12? All right, 12's good. All right, if I'm going to go back to the derivative, I'm going to go back to the factored form of the derivative. 6 times 12 would be positive, and you know what? I don't care that it's 72, guys. I just care that it's positive. And 12 minus 3 is positive. So a positive times a positive would be what? Anybody? I get a positive. Positive times a positive is going to be
Positive.
positive, yeah. So right there, I have positives. I picked a test point, 12, 4, whatever. Now what it tells me, and you might as well go ahead and write this, is that this thing here is increasing, and you can write it there if you want to. We're going to write it in an interval in a minute, but it's going up. Oh, man. Hang on. All right. So it's going up. So that means it's increasing there because it was positive, because we had positives in there. Okay. Let's look between 0 and 3. Pick a number between 0 and 3. Don't care what it is. Simple as possible. Give me something.
2.
2. 6 times 2. Don't care if it's 12. It's just positive. But 2 minus 3 is negative. So positive times a negative is going to give me a negative. That's how that goes there. Okay, so around between 0 and 3, and again, all I picked was 2, put it in here, they're multiplied. So it depends on how they're interacting together, guys, not just how they are individually. That's why it's easy to see from its factored form. You could plug a 2 into here and find out that it was negative, but in its factored form, it's a lot easier to see that, okay? So what that means here is that that's decreasing around 3, okay? That's decreasing. So it's actually, and everywhere in that interval, it's decreasing. Okay, so that takes care of that interval. All right, let's go back to the left of 0. Pick something to the left of 0. Don't care what it is. -1, all right?
Yeah.
6 times -1 is -6. -1 minus 3 is -4. Minus times a minus will be a plus. Okay, I just picked -1 or something back here. -6 times -4 is a plus. Minus times a minus plus. So what that says here is that you get plus positive derivatives in there. Now you're plugging it into the derivative, guys, not to the original function, but to the derivative. That means it's increasing there. And so I'll draw my little arrow and say it's going up. All right, so here's what I'm going to do. I'm gonna roll this up just a little bit. I actually did the problem down here again. And that's the stuff we got there, guys. We got increasing, decreasing, increasing. Now, the critical numbers were 0 and 3. Just a repeat of what I've done on the previous screen. All right, and right here, I know where it's increasing, I know where it's decreasing. Now, if I ask you where it's increasing or decreasing, if we went over here to the right and I said, where is it increasing? You would say -infinity to 0, because that's where you see a positive. It's also increasing, and I'll put a union there, from 3 to infinity, the other place where it's positive. So positive places mean increasing. Where is it decreasing? It's decreasing between 0 and 3. So right in there where the negatives are, it's decreasing. Okay, now, need a little help here. Clearly, those are important places. So 0 is an important place, and 3 is an important place. But before I graph what's going on, let's find out a couple of points on the graph. And you go to the original for that. What's f of 0, guys? In other words, what's the y value at 0? That's actually pretty easy to see. If I plug in 0 here, it would be what? Well, twice 0 cubed minus 9 times 0 cubed is just going to be 0. Okay. So 1 point on the graph is actually the point 0, 0. So that's good news. It's easy. The 3 cubed is 27. So that's 54. Minus 9 times 9, 9 times 3 squared is 54 minus 81. What is 54 minus 81, guys? Let me write it down here. So I'm doing f of 3 now. That's right, 54 minus 81 is 27, minus 27?
Yeah.
27, all right? Okay, so way down here, and I kind of cut myself off, guys, but way down here is the point 3 minus 27, okay? Is everybody okay with that? I'm getting points from the original. I get increasing and decreasing from the derivative. Okay, I'm gonna draw a sketch of this thing, and it might not hurt to get a couple more points, but the beauty of this is that you can get a general idea of what the graph looks like without doing that. If you look here to the left of 0, it's increasing, so to the left of 0, it's got to be coming up to that point right there. It's increasing. What was it doing between 0 and 3? Well, it was decreasing. So when it gets to 0, I go back down and it's decreasing until I get to the 3. Then what does it do after 3?
Increases.
Notice it increases, which means it just starts going up again. Now, guys, that's a pretty powerful thing, because that's not a function that would have been easy for you to graph before now. okay? So, I mean, but I get a general idea. Now, it might go up faster. You can plug in 4 if you want one more point to kind of nail it down here. I mean, if I plotted the 0.34, then it would increase through that point. Or if down here, it went through a point down here, it would just decrease through that point. But the general look of the graph is that. And I encourage you to put these on your calculator and say, yeah, that's what it looks like, okay? That's generally what it looks like. All right, so let me give you some guidelines here. The guidelines for doing this, for increasing and decreasing, look like this. The first thing you do is find the derivative, okay? That's what we did when we took the derivative. The next thing we did was find the critical numbers, and we did that by finding out whether the derivative is 0 or fails to exist. I'll give you an example of that fails to exist in just a minute. We draw a number line, and we put the critical numbers on it. Then we plug in a test value to the derivative now, guys, from each portion of the line. If you get a positive, it's increasing. If you get a negative, it is decreasing. So that's a very nice thing we can learn from the derivative. Let me show you something else. One other short thing under here. Suppose I had f of x. Do I want extra pages here? Let me try to get some extra pages. I'm not getting my extra pages that I want. Okay, I'm gonna come back. I'll show you down here. If I look at a function, f of x is the cube root of x. The domain of that is all real numbers. If I'd wanted to differentiate it, I'd write it as x to the 1/3. So domain again, minus to infinity. So this function exists everywhere. If I took the derivative, it would be 1/3 x to the minus 2/3, which if I rewrote would be 1/3 root 3 square root, cube root of x squared. Cube root of x squared. The function exists everywhere. How about the derivative? Is there any place where the derivative doesn't exist? Guys, look at it carefully. Is there any place where the derivative doesn't exist? Well, you got a denominator to look at. Anything that would make that denominator 0?
0.
Yeah, 0. So that's also a critical number. So if the function exists there but the derivative doesn't, that's also a critical number. I would do the same thing here. I would put it on a number line, and I would test that derivative. So for instance, if I looked at 1 squared is 1. Cube root of 1 is positive, so it's positive over there. Over here to the left, if I plugged in -1, when you square -1, you still get a positive. Cube root of a positive is positive, you get a positive. You get a picture that looks like that. I mean, you get something that's like that. And it says it's increasing everywhere, except it's undefined as 0. I'll tell you what this thing looks like. Kind of looks like that. And I've got it increasing. Notice, I've got it increasing everywhere, and it's got a vertical tangent line there. That's an indicator. That came from this. That's where the derivative is undefined. This also happens at sharp points. So that's one thing you need to do there. Or an example, and we'll look at it. We'll look at more of those later. Okay, I'm gonna go do another example. Look at this one. What's the derivative here, guys? What's the derivative of x cubed? Well, we've done that a couple of times. That's 3x, whoops, that's 3x squared. So 3x squared minus, look at this one right here. I'm gonna bring the 2 down. It's gonna cancel, and I'll get minus 3x. Okay, everybody okay? Everybody on board with the derivative? Guideline, first thing, take the derivative. Second thing, find out where it's equal to 0. In other words, you're finding the critical numbers. To do that, we're going to factor. what do you get? What'll factor out of that, guys?
3x.
3x. This one looks almost too much like the other one. X minus 3. Those are your critical numbers, would be x equals 0 and x equals 3. So I put on 0 here, 3 here. If you test it in there, to the right of 3, it's positive. If you tested a 1 in here, this would be positive, that would be negative. So when I multiply them, I get a negative. If I put a negative 1 in here, that would be negative. Negative 1 minus 3 is negative. Negative times a negative, that. So this would be increasing, decreasing, increasing. In interval notation, increasing minus infinity to 0, union 3 to infinity, decreasing from 0 to 3. Okay, you can put the little arrows in there if you wanted it. It would help you graph it. Okay, so decreasing, increasing. If again, I wanted to find the points here at 0. If I plugged in 0 to this function, I would get 0. If I plugged in 3 to this function, I would get 9 minus 27 halves, whatever that is. So 9. Oops, I'm plugging in. Sorry, this is, let me get this off. Let's make it bigger. So I'm just plugging that 3 into the function there. Actually, it's not 9, it's what? It's 27, I think. 3 cubed would be 27 minus 9 halves. No, 27 halves. I'm sorry, I'm running out of steam here. 3 squared is 9 times 3 is 20 minus 27 halves, whatever, which would be 27 halves. Okay, so if I go up here, I'd plot the point 0, 0. Let's get up a little higher. I plot the point 0, 0. I plot the point 3, and that's 27 halves, which is close to 14. So 3, 27 halves. You can do that on the calculator, however you want to compute that. Now we knew it was increasing from minus infinity to 0, and decreasing from 0 to 3. So increasing here, whoops, sorry. Increasing 0 to 3. Between 0 and 3, it was decreasing, and that point, I've got a wrong point on there somewhere. Increasing, decreasing, then it would start increasing again. This should be, that's got to be negative to make this work. I'll fix that later, guys. I'll come back and fix it in a minute. But anyway, you see what I'm trying to get at. What did I do wrong? Got 0, 0. Plug in 3 to the function. Got 27 minus 27 halves. Anyway, something's going wrong with the way I did it or tested it. All right, let me go up. One more real quick one. I'll fix that one later. Don't worry about that. F prime is going to be 3x squared minus 6x plus 3. I just want to show you this to make sure everybody's on board here with what you've got to do. Take the derivative. Notice 3x squared minus 6x plus 3. You want to find the critical numbers, which means you need to factor it. So I'm going to factor out a 3. What's left is this. That's a trinomial. It can be factored like that. What are the critical numbers there, guys? Actually, there's only one critical number. What's the critical number there? Where would that be? 0.
1.
Just at 1. Yeah, that's the only critical number there. So when I'll put that on the number line and look at this to the right and left. So if I pick 2, 3 times 2 minus 1, positive. 2 minus 1, positive. 3 times a positive is a positive. Oh, let me show you one other thing that some people do wrong. They say, oh, I'm going to put 0 on the number line because this 3 could be 0. That doesn't even sound right. 3 can't be 0. If there was an x with it, the whole thing could be 0, but 3 is just 3. You don't get a 0 critical number out of that. All right, now, to the left of 1, say it 0. If I plugged in 0 here and 0 here, I get 3 times -1 times -1. A minus times a minus is a positive. That's interesting. It's positive on that side. Okay? So 1 is a critical number. It's increasing on both sides. What I'd wind up with, if I plotted it, plugged it in, let's see, it's 3x squared minus 6x. If I plugged 1 in, I'd get the point 1, and plug that would be 1. That would be 1 minus 1, 1 minus 3 plus 3, which would be 1. So got the point 1, 1 on there. Right, so if I got the point 1, 1 on here, there it looks like that. Now, this is an interesting graph. It doesn't look like what we were doing before, but look what it says it does. It says it's increasing until I get to 1. So it increases right there. But then what does it do? What does it say it does after 1? It also does what?
Increases.
Increases again. So really, what happened there is it just flattened out for a second. Instead of decreasing, it keeps on going up. So that there, if I drew a tangent line there, it would be a horizontal tangent line. So this a critical number happens there where the derivative is 0, but it just keeps on going up instead of turning down again. Okay, that is all I got to say for today. So what you should be able to do on this, and I want everybody to be religious about their homework, okay? Because when we come back in tomorrow, I want questions on this so we can look at what's going on before we move on. That's the only way I'm going to be able to read what's happening in the class. So I believe, let me check my assignment sheet. I believe that's what I wrote on the assignment sheet. 1, 3, 5. Well, actually, 1, 3, 5, 7, 8, 10. On the assignment sheet, it says 131. It's not 131, it's 13 through 21 odd, and then 25, 33, and 35. Okay, it's right. Except on the assignment sheet, this like showed up as 113. It's not 113, it's just 13. Okay, so questions, anybody, before we say goodbye? Everybody doing okay? I'm going to try to get your tests graded. If you do not, you need to get your test into me right away, because I'm also turning in midterm grades this afternoon. You will not get a midterm grade if you've got a C or better. I only turn in midterm grades if they're C- or less. If they're C- or less, think of this online thing as an opportunity to pick yourself up, okay? Because in this pass no credit fail, or pass no credit thing, it's not pass fail, it's pass no credit, but you have to make a C- to pass. I do have the option of giving you a D so you wouldn't have to take the course over again. We'll talk about that in individual cases. But when you get your midterm, think about the implications, and I'll talk to people individually and personally about that. Okay? Everybody okay? Wave goodbye. I'll see you tomorrow, okay? All right. Later. I'll put this up on Moodle. I mean on Moodle this afternoon. I'll put the video up. All right. I'll talk to you tomorrow.